For at least a couple of decades, we have been writing software from the bottom of a carefully crafted data model up to whatever front end could make the software usable by end users. In all this time, we have found out that most of the required business actions could be mapped directly to low-level database actions, insert, updates, and like. Here is the basic algorithm we all followed. First off, make sense of functional requirements. Next, based on the knowledge acquired, build a relational data model that could be used to implement all relevant tasks. When done, find a visual way to make the whole thing usable by end users. And when you're done, stop and ask, does it work? Yes? Great. No? Repeat from step 1. For a long time, things, business logic, actually, haven't been particularly complex. And once you had identified relevant tables, tasks, and their interconnections, most of the time you were pretty much done. At some point, though, things started getting worse. And here in this context, getting worse just means that things started getting a lot more complex. So using the same approach to work with many more relevant tasks and many more interconnections became unmanageable. Domain-driven design is an approach to software development that is pretty common nowadays, but it emerged specifically to tackle and tame the complexity of business domains. Domain-driven design is made of two parts. One is strategic design, and it is aimed at identifying the language, the lingo of the business and subdomains that are better treated as independent systems. In the domain-driven design jargon, these subdomains are called bounded contexts. The other part in the domain-driven design is implementation. The implementation of a bounded context is centered around the idea of a software model that is consumed in a layered architecture made of presentation, application, domain, and infrastructure layers. The software model is often rendered as an object-oriented model, but that is in no way mandatory, as other possibilities are valid, such as a functional or even a procedural model. Early adopters of domain-driven design found it difficult to design a single comprehensive model able to cover all possible aspects of the business domain. The trade-off between the design effort to put up front and the cost of fixing things that change or things that at some point are better understood by the team suggests avoiding the use of a comprehensive model for something more specific and especially something simpler. At the end of the day, on a software system, you perform only two types of business actions: commands, related to the application of known business rules, and queries, related to reporting very well-known views of data up to the user. A query is an operation that doesn't alter the state of the system. A command is an operation that instead modifies, alters the current state of the system. Any business action in any software system is either a command or a query. And because of that, why not splitting the software model in two parts? And this is exactly what the CQRS pattern suggests you do.